Hello, everyone. I hope this recording finds you well and happy no matter where you may be. I wish I was there to buy you a drink and hang out, but we'll be doing that next year for sure. So here's my session, IQ devices, where are they now, and who's using them and for what? And I thought I should bring in some other people to help us do that. So I have Les Lasarzak. I probably mispronounced that, Les. I apologize. He's going to talk about the Yoo-Hoo device specifically. I got Steve Mann, who talks about the Yoo-Hoo and the Aware element. Linda Wigington will talk about why one device may not be a fit for what you're trying to accomplish. And she's also really the founder of a lot of the stuff that we're doing and we'll talk about today and what she does with hundreds, if not thousands of people and all the data she's gathered. Kevin Kennedy will kind of shock us to death at the end here about what are the health impacts and why we're monitoring for this stuff and what we should be thinking about when we're breathing. Steve Byers will provide some information about why these devices were made by a bunch of people who don't use them because there's a challenge or they give us information that's really hard to understand. Caleb Saleeby, who's a great expert on IAQ devices, will also talk about the Katera device, Katera Ag, specifically the CO2 device, and also the new ZOA device that also monitors your duct system. Brett Singer will explain what's real and what's not and give us some background as to what we know about them and why, and some really good foundations about some of the stuff that we all think we know about. And they'll show you what kind of research they've actually established. And I have some links to the most recent papers. Bill Spohn, who is a legend in all of the things we talk about, he actually has an amazing, not just ERV, but something that actually does conditioning and a variety of stuff. So we'll talk about the Serve unit that he has in his new house and how it monitors and conditions and recirculates the air in his house. And Peter Trost will join us to talk about what he's doing in his office space using his Aware Omni device. So a lot of information. Of course, I gave everybody around 5 minutes. None of them could do a 5 minute session. They all thought they could. They showed up with 12 or 13 slides. I'm like, well, we've already failed. So I had to edit them dramatically, but there is a link at the end of this recording where you can see everything we talked about, including my own session, which I had to probably edit. So we'll see how much we get in, and there will be a link to see everything. So I appreciate you tuning in. Let's dig into the real challenge that I did not talk about with anybody. So I want to make sure that I stress this right up front is that you, the occupant, you, the person who is in these environments, are way more sensitive than any device that's on the market. Any 100,000, $300,000 device, $10 device, $100 device, none of them are as accurate as we are as human beings. Our olfactory and our senses are so much more sensitive to our environment and impact us. In fact, many people go looking for these electronic devices to help confirm or deny the experiences they're having in their homes. And this is always a challenge because they're never as accurate as we are, especially if you're hypersensitive to some of the conditions, especially VOCs or particulates. These things can really impact how you live in your home and why you could be frustrated in your environment. So these extra devices may confirm what you're experiencing, but by no means will they actually compare what's happening. You may have this measurement, and one person has severe symptoms, and the other person says, "I feel great in this room." So they are a challenge. But the device is trying to give us a measurement, an independence tool that we can say, "Oh, here's what's in the room according to this device at that time," and then we can make some decisions about what we should be doing, whether it's more ventilation, more filtration, or changing the habits that we're actually using that environment. So what are you breathing and how much of it? So this may be kind of somewhat of a shock, but every day you breathe a 10 by 10 by 4 foot pool of air. That's 3,000 gallons of air every day. So it's constantly moving throughout your lungs. We'll talk about particulates in a second and how deep they go. A lot of stuff gets caught early in your breathing capacity, and some of it goes far all the way down to ends up in your direct bloodstream. So you may not know, this is Larry Zarkar with BPI. So I made this prop for him years ago. They weren't using it enough, so I said, I'll take that back. So, but LBL Labs confirmed that an average 2x4 wall that's got fiberglass insulation may work as actually a MERV 8 or even as much as a MERV 13, which is an amazing filter. But you don't know really where it is or where it's failed. But do not use your envelope as a filtration system. But this is what you're breathing. If you do not have a direct path of doing fresh air supply, you are breathing your house. You're breathing your crawl space, your walls, your attic, wherever you have air leakage and infiltration, that's what you actually are breathing. So be aware of what you cannot see and how what it actually does to your body. You have seen this from the EPA. This is a common illustration. I try to modify it so you could see the real size of a blood cell, a bacteria, and this dreaded SARS-CoV virus that's haunting us for the last year. So we think about PM 2.5. A lot of things we're going to talk about today, PM 2.5 is rather large, right? All of this colored scale is over here on the upper left. So you can see PM 2.5 and 10 and where they actually go into the lungs and where do they get actually caught or actually end up in the bloodstream. So you can see that all of the stuff that's super green, right, is actually going deep, deep into your lungs. As one of the first examples I have, I want to talk about the filtration system. Linda Wigging is going to go into more detail about this, but I just want to make sure it got caught on this video early because they do a great job of not just doing these upgrades, but showing the particulate reduction that actually happens, as well as the energy savings that go along with changing your motor and actually changing how the filter goes through your system. So do make sure you catch Linda. It probably may be in the extended version, but if not, we do talk about what they're doing. She's near Pittsburgh, where they have a lot of particulate challenges. So running your air handler all the time to them actually makes sense. It could be around $11 a month when you change out the motor, and they get a drastic amount of particulate reduction by using a MERV 13 with low static pressure through their system. Definitely something we should be all achieving to. This isn't something that's unique. These are things that are maybe happening all the time. So this is Kalos out of Florida. Caleb is with these guys. Caleb Silleby, he'll be on here today. So they're talking about what they normally do. They go, they make sure they clean up the return, make it a nice large clean path, and do a much better job of getting a large filter in place that has a high MERV rating. All these things are outlined in the EPA Residential Air Cleaning Guide, which talks about filtration systems. There are multiple devices out there. Of course, we would not be able to talk about all of them. Some of them are really not even worth talking about. Some of them are truly amazing. You can email me directly at the end here, and I will tell you what I think about many of them. I own most of them. I've tried most of them or know more about them. So there, I divided them into three categories. Well, one, two, three, five categories. All right. These are personal devices you kind of like have with you all the time, put on your bike, put on your backpack, put on your hip when you walk around. They're really just something to kind of give you what's going on outdoors or indoors or whatever you're at. It'll track you in a general manner. A lot of them are Bluetooth, which is a serious challenge to actually get the data onto your phone, which is the only place that it can do that. You got to be really close to these devices, and they're really challenged to work with anybody else or even work with your own home. I got to go down to my basement to get some of the readings. The other ones that are really phenomenal, and Linda Wigington and others use these are PM 2.5. They're specific to only do one thing and do it well. Most of the units fall in this Wi-Fi category. There's a whole bunch of them. In fact, I'm sure I'm missing three or four of them that you probably have, and you're like, mine's not on that page, Joe. So, but they mostly just focus on a Wi-Fi connectivity, so you can access them anywhere where you have internet. And then there's a few that you actually do 4G. This is actually the Air device, and it actually is a focus for a contractor engagement. So we'll talk about that a little bit tonight, today also. So these are all consumer IAQ monitors. Some of them are more on a pro level. Some of them can work on a commercial level, but in general, these are designed to be regular consumer, ma and pa, you and me kind of devices. They all range between 150 to 300 and maybe $700, depending on what you're looking for. By no means, if you pay more, do you get more? That's one of the challenges that goes along with the learning curve. So I identify them as trend indicators. Brett will come on in a few minutes and explain that they're really more than trend indicators if it's a good device. It actually will give you solid things to focus on with PM 2.5 and actually carbon dioxide. So what are the conditions? Where in the house? How long is it measuring and when? When will you get the data? How will you share it? What will you know occurred in the home? Were people showering? Are the windows open? All these are some of the challenges that go along with, not just you using it, but if you're trying to find out more about what's happening in an environment. I'm hoping that maybe there's a few builders or raters or something who have an issue in a house. Maybe it's their own or somebody they know, and they're trying to figure out what is going on in this house. Why are the VOCs super high, or why are the particulates or carbon dioxide super high? All these things are determined on what you need to know about the device, when and where. And if you only had a doctor's visit and he was only there for 3 minutes, you'd wonder, wow, that wasn't worth my time. You probably can't determine anything about what was happening. So the longer the device is in multiple locations, the better chances you are to have some kind of data that you can make solid decisions on. So they are trend indicators for the most part. They are at that time that they are on and that location. So if you had it in your bedroom for 4 hours, but you didn't use it there where you're sleeping, you really didn't get a good job, do a good job of understanding what it can provide for you. So you do want to make sure if you mostly only have one, I do recommend you have two, but in general, if you have one, you should be moving it around every couple of days and taking a log, keeping track of where it is, when it is, and what's happening. When were you taking showers? What were you cooking? All those things will help you understand more about the data that you're getting from these devices. Imagine if your IQ device was just a bulb and you only had one bulb in your entire house. The only way to see anything in your house was with this one bulb. You walked around with a long extension cord. You could turn it on. Maybe it had batteries, whatever. So you could only see what was going on in this one living room because that's where the device or the bulb was. If you took the device to the bathroom, you would only understand what was happening in the bathroom and see what you were doing. Same as if we went in the kitchen, which actually probably has some of your highest levels of particulates you may get out of anywhere in your house. If you have higher particulates somewhere else, then I'm curious as to what the heck is going on in that room. Or it's in your office. So any of these things, or a bedroom, any of these things could say, okay, I can see what's going on in that area at that time, and that's it. You do not get a whole house understanding. Of all the slides I got, I think this is probably the most powerful one because this is what people think of when they think about an indoor air quality device, and that it's like a blood test. That it tells me so much about my house and all the things I need to know, what I should do, what I shouldn't do, what behavior should I change, or should I cook differently, or is my exhaust hood working well when it's up in my bedroom? You could kind of know that if your exhaust hood isn't working well because you have indications in your bedroom that you're cooking. Depending on how far away it was, that even gives you more indication. But in general, it's really not intended to be the same type of diagnostics as we think of as a blood test. It's not comprehensive, nor does it tell me everything I need to know about my house or my habits. It gives you an indication about what things are going on, again, when and where it's happening. These are some of the measurements that many of these devices are doing, right? So temperature and humidity, very common. I don't know if there's a device out there that doesn't do those. Carbon monoxide, some of them do, some of them don't. If you have a carbon monoxide issue, that is serious and deadly. Radon, very few of them do it. If they do it, they usually do it very well. They may not do other things as well. So PM, particle count and mass, TVOCs, that's total VOCs. We'll talk about that. Brett does a good job of explaining the limitations of that, including formaldehyde, which kind of gets mixed into the bunch. Some may do formaldehyde directly. Again, sometimes our sensitivity is so broad that you actually exceeded the scale, so you're trying to actually compare it to. And of course, carbon dioxide, one of the most fundamental measurements we'll do between that and particles, PM 2.5 or PM 1.5 and 10. Ozone, only a few of them do that. Some of them do air pressure and barometer. Some of them do ambient light, lux, sound. So those are things that are more of a high-end well or reset certified type of a building. So of these, there are only a few that are really are considered like, wow, this is a very good, accurate sensor that's in the device. So the sensor and the device are really separate. So think about them that many of these devices we'll talk about all have the same sensors. But temperature humidity is usually pretty accurate unless they didn't do a good job of keeping track of how much their own device impacted those things. Brett and I talk about that also in our section. So what data do you get and how? Oh, wait, let's go back.
There are quite a few devices that have both CO2 and PM 2.5 sensors that are basically accurate enough to provide you with actionable information in your house.
There you go. Particle and carbon dioxide, those are fairly accurate today if you have a good device. So what are you getting and how? Is it on your phone? Is it on a tablet? Is it on a computer? Is it both? Is it a piece of paper you print out? You need to understand, and many of the people reminded us about that. If you need to know what's on the device, how the device works, does there something on the device that gives me information, or is it just kind of blank? Does it glow? Is there some indications, some LEDs, a number? Those are the things that make this really fundamentally useful for you or whoever is using this device, right? So if you have no idea how to interact with the app, or the device only just glows, red, yellow, green, I don't really know exactly what that's telling me. Probably there's something bad, something good, but I really want to know more about this. And now I got to go figure out, where do I find that information? So there are some things that tell you on the device directly. So that's a great thing. Some of them have a dashboard. That actually costs a lot more money. Most of them do not. It's only in the app. But in general, some of them do. A couple of them actually give you a written report so you can talk to a client if that's actually your business model or that's what you're using these devices for. All right. So there's a lot of information, and most of the stuff is kind of technical or dealing with devices. But let's talk about the interface and how they can or cannot be friendly or user friendly or get us to do something. So I got Steve Byers on the as my next guest. So Steve, why don't you introduce yourself and tell us what you want to talk about?
Hi, I'm Steve Byers. I'm the CEO at Energy Logic, and I want to talk about what in the computer world terms I pulled from there, really UI and UX, but they really apply to what we're talking about. I think in terms of UI is user interface and UX is the user experience, and both of those things really play into the overall efficacy, if you will, of these devices that everybody else is bringing all the technical wizardry to. So I'm going to be talking in a little bit different sort of space about these things.
Do you have something now that you're using that you're like, oh, I wish it did this, or other experiences with some of the devices?
Yeah, I mean, and I don't have the breadth of experience with different devices that some of the folks that you have, Joe, and some of the other folks that are going to be on this panel have. I've had direct experience with more than just these two, but these are the ones that I've had the primary experience with. Have both of these in my house. I've had them running simultaneously against each other, which is a whole nother topic. Running these devices against each other to see what they agree about and what they disagree about is sort of fascinating. But these are the two, and I titled this noise or signal, and the reason I titled that is that these are in our homes now, and as we walk through our daily life and walk through our home, they're sending us personally a signal, sending it to our eyes or our ears or whatever. And it's meant to do something, but if it's no, is it noise or is it really a signal? Because if it's a signal, if you get a signal, then you understand it. You understand what it's saying, what it's conveying to you. If you get that and it's not conveying what it's meant to convey, it's actually noise. And so, I think these different devices, and they all have their strengths and their weaknesses. I'm not here to throw anybody, any particular device under the bus, but the experience that we've had with the Foobot was that, and I'm going to get to a little bit more about that in a second. Okay, it's blue. Okay, great. Everything's great, which is what they're trying to convey. So that perhaps works. But as soon as it's not blue, it's just a varying shade of orange. And well, of course, there's the shades of blue as well. And I don't really know without getting out my phone or my iPad or getting on a device what it's trying to tell me. And even I can tell you, even understand that these things are evolving all the time. But even when you look at the device, and I can understand them, but in my family members, even once they look at the app, it was still Greek to them primarily. And I contrast that with the Aware because, for one thing, it's got a numerical scale. So how bad is it? Okay, I get it. And in pretty short order, family members were able to discern, what the bars meant. And, they could correlate the bars to the number, and they felt at least like they didn't, yes, there's an app also, but they didn't have to get out an app to do that. And especially these days, I find a lot of people would rather, not be forced to go to their phones if they don't really need to. So that's
How
what.
long before a signal does become noise? Like how long before we just don't even look for something? It just becomes like, okay, usually I think it's about 30 days for these devices. They have a novelty and then suddenly it kind of is a noise factor in the background.
It's a great question and a good segue, Joe. And I want to talk about that a little bit more. Our experience going, thinking back to the Aware is that for both myself, which I try to take myself out of the equation because, we're geeks for this stuff, but my wife, we've had the Aware now for 8 months, 6, 8 months, something like that. And it's not noise to her. Even today, what that device is telling her is not noise. And when my daughter just moved back out of the house, she understood it too, and it wasn't noise to her either. So I think it depends on the device as to what it becomes noise. And I put this slide up to talk about that. I called it fatigue, but there's also terms also alarm, desensitization. We, like as you said, we just become immune to all the stuff. I mean, we're in information overload constantly anyway, right? And so, there's a little bit of the crying wolf too, like, oh, you're orange again, but everything's great. It's like, there's no obvious reason why you're orange, which may or may not, be valid. Mostly it's not valid. There is a reason, unless the sensors are having problems, but people just start to ignore them for sure. And you may be going, well, okay, other than the fact that almost all of this stuff comes to us via Amazon now, that's not why the truck is here. The truck is here because I had the experience in doing a little background information on alarm desensitization. The construction sites that most of us have been on, are one of the places where this is rife. It's almost epidemic, if you would, that people ignore alarms. And in particular, we all have heard the reversing alarm. When you go into reverse in a forklift, a truck, whatever, we get wah, 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 right? And we all ignore it now. And I had the experience a few days ago of hearing a prime van like this go into reverse, and it was like a quack, 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 and it immediately got my attention. And so it says something about, you've got to maybe mix things up too for really important alarms, right? If every alarm is an emergency, then we'll ignore them.
Steve, that was some phenomenal insights about challenges and user interfaces and what do they do or not doing. And we learned that Amazon trucks back up with a quack. So I appreciate your time for being here, and I look forward to seeing you in person sometime in 2021.
Absolutely. Thanks, Joe. Take care.
Here's the one condition that almost all of them have. They have this AQI, air quality index. It's specific to that manufacturer. They're all very similar. Some of them trying to get to 100, very common. Some of them trying to get to 0. 0 is good, 100 is good. And then they have some conditions where if your humidity is low or high, that actually impacts it, or your particulates are high. Whatever it is, usually it's the largest condition that it's monitoring impacts your air quality index or your AQI. So they're not necessarily comparable one to the other. So one of them on this device has a 59 and the other one has a 23, but those both may be kind of good or yellow. Anyway, I encourage you as a general use that these are things that are the ultimate trend indicators. If you really understand or like the numbers, then this is one of the most useless things that's on the device is this thing that I have to get around or see through to find out what's really going on. So if it is it should be 100 and it's actually now 23, I got to figure out why is it 23. I got to go find those numbers or those conditions to figure out what's bad to understand what these numbers mean. So I got multiple devices. Let's dig into hear about what some of the people are talking about. So you can see there's a lot of devices out there that I've kind of given overview and that these are kind of trend indicators, but I thought I'd find some of the people that are using them in their own homes, in their own situations. So my next guest is Steve Mann. So Steve, why don't you tell us about yourself and what you want to talk about today?
Sure, yeah. Thanks very much, Joe. I've been an owner builder for over 30 years doing a variety of projects. And for about the last 15, I've been working as a consultant for people that are doing high performance residential projects. I'm personally a passive house advocate, and that's pretty much all I do anymore professionally is work with people on passive house projects. I think that's the wave of the future, and that's where we're going. We just finished our passive house about 18 months ago, moved into it, and it was interesting. Passive house likes to talk about the indoor air quality. And I thought, okay, well, I've designed and built this thing according to what they say. Let's check out the indoor air quality. So I first bought a Yoo-Hoo device because it measured 8 different things, and I'm thinking 8, I can't even use 8, so I'll go for that. And it was about $300, so it was affordable. And I wasn't going for laboratory level quality. I was just going for indicators. Started with that and put it in the master bedroom and started realizing that we were having issues with carbon monoxide and with nitrogen dioxide.
Hmm.
Carbon monoxide was understandable because we like to keep the bedroom doors closed so the cat doesn't come in the middle of the night. And it was interesting, despite keeping a window open and creating an air path to other parts of the ventilation system in the house, that did not mitigate the carbon dioxide problem. It wasn't terribly bad, but it was enough. So I was thinking, well, we really shouldn't have this when we're sleeping. But it was, between 600 and 1,000 parts per million, which is considered not great, but not horrible. The nitrogen dioxide, I realized, came from the freeway that we live about 8 blocks from the commute traffic. And it was amazing when the COVID lockdown started, the nitrogen dioxide levels dropped to almost nothing for about 3 or 4 months. So very, very educational. I love these things. After I got the U, I thought, okay, well, we're cooking in the kitchen now. We've got an electric cooktop now. And again, we've got this great ventilation system. Let's see what's going on out there. And so I put the Aware device out in the kitchen. It measures 5 things. It's got a cool little interface. It's got those little LED indicators there, and it's got a score, and it tells you your overall air quality. It factors in all these 5 things. And again, it's carbon monoxide, carbon dioxide, VOCs, PM 2.5, and humidity, I believe, and temperature. And it sort of throws those in a formula and gives you a number. And this is very predictable. Turns out that when we cook, the air quality in the kitchen goes down. No surprise, but I was thinking, well, the induction cooktop, they should be throwing off as much toxic air. And I'm guessing if we still had gas, it would be even worse. It's not bad, but again, it was very educational. So as far as I'm concerned, whenever I have a client now that wants to build a house in a particular location, I tell them to get one of these devices and put it in the house that they're going to tear down and measure the outdoor and indoor air quality to see what's going on. And put it in their own house if they're just living in their house. Excuse me, because you never know what's going on. This stuff is invisible and it's quiet. And you may think that your house is awesome and healthy and everything else, but you don't know if you don't measure. And I was surprised that a lot of our indoor quality parameters were really good. And I was also surprised that some of them that I thought were really good weren't nearly as good as I thought they were. So everybody ought to have something like this. Absolutely believe that.
Okay, so Joe, once again, there are many devices available that have accurate enough CO2 and PM 2.5 sensors to allow you to take action in your home to improve your indoor air quality.
So what are some of the pros and cons about these devices specifically that you're like, there's never a perfect device. At the end of this, I've got to think about this is my perfect device, which doesn't exist right now. But is there something you were like, let's talk about the pros. Let's start with positive. What did you find positive about each of these?
Okay, for the Yoo-Hoo, I like the fact that it measures 8 things. That's, like I said, that I can't imagine even needing 8 things, but I like to have the information. On the Aware, I like the fact that the user interface is really designed for non-scientific, non-nerdy, ordinary people. It gives you a number. Like in this particular case, 92 means, well, 100 is your air quality is great. 0 means your air quality is horrible. And so a 92, it's like indicating, okay, it's pretty good. And if you want to dig down into the details, you can by looking again at those 5 little LED things on the bottom of the screen there. It identifies which categories are causing problems so that your score is dropping down to 92. They both come with iPhone apps, so you can look at the stuff on your phone. They'll do notifications. That's nice. So if your CO2 levels are peaking all of a sudden, you get something on your phone that says, wait a minute, you've got a problem here. I like that. The thing I don't like about both of them is there's no way to collect this data offline and say put it on a laptop and do any kind of analysis on it.
This was some phenomenal feedback and information about not just the devices, but how they can they change your behaviors, and they change how you think about your house and what you did to your house and what you tell your clients now. So,
Yeah.
Steve, I can't thank you enough for not only what you do for the industry and other stuff. I've learned a lot from you in the past, and many people have. So, thank you for that, and thank you for being here and sharing your experiences.
Oh, you're quite welcome. Thanks for the opportunity, Joe. Always fun to talk to you.
I look forward to seeing you soon in person somehow, some way. Thank you.
Somehow, some way. All right, good. Okay.
There's a couple of devices I want to talk about. We didn't really mention them with the group. So one is Purple Air, and they have an indoor and an outdoor. So this is an outdoor. They have. I'll put the link at the end with all my other stuff. You can actually go online and see all these. This is one of the greatest databases of outdoor air pollution that we have right now, similar to what Linda Wigington is doing in Pittsburgh. She actually uses these. So you can find one that's close to your house. You can find one if you're traveling. But in general, these are really not that expensive, and I have one at my house, so I'll try and share my results with you. But they are giving really what they consider to be accurate data for an outside device that's designed for consumers to use. This is their map, and you can see where the wildfires were last year over there in California, and it's just kind of showing you some of the conditions that are around the country in general. So you click on one, see what they are, see some of the past results, to see the trends. It's a pretty amazing device that's out there. All right,
Okay.
so my next guest is Caleb. Caleb, why don't you introduce yourself and tell us what you're going to talk about?
All right. Yeah. It's a pleasure to be here. And I work for Kalo Services along with HVAC School as a trainer. I do record podcasts, I write articles and everything, but I do a lot of indoor air quality as well and consulting. And what we're going to talk about a little bit today is indoor air quality sensors and two specific types of sensors. One will be the ZOA Haven and the Katera Laser Egg, specifically the one that measures CO2. So yeah, that's what we're here to talk about today.
So let's talk about the ZOA device and where is it? It's kind of a new device that works in the ducts. Can you kind of explain what it is and what it's monitoring?
It is a new device, and it's something fairly different than your standard room monitor. This is what it looks like, and it's an invasive monitor that gets installed inside the ductwork. And typically it's the return ductwork that you can do it in the supply, or sometimes you can even install them on your ERV, your fresh air intake, to monitor indoor air quality. The incoming.
Can you pull your device back up? Pull your device back up.
Yeah.
Show us that where it would be in the duct. So you just kind of use your hand or something to be like, yeah.
So if this was the return duct here, we'd be putting it inside, so we could have a little space bar here, and this would be attached to the duct. And this is going to be measuring air the main thing about this particular monitor is that there is no internal fan. It is passive. It's reliant on the HVAC fan for airflow through the device. And so what this means is that all of the readings that it's taking are representative of a holistic perspective on the home. So it's a more holistic point of view of the indoor air quality inside the home on average. It's not localized like a room air monitor would be. And it's not dependent on, a dusty internal fan. Sometimes there's, we'll talk about that in a second. But a lot
What is it monitoring? What does it monitor?
It monitors TVOCs, temperature and humidity, and particulate, PM 2.5.
And it's Wi-Fi? Is that its connectivity is Wi-Fi?
Yes, it is Wi-Fi. And this particular device has a counterpart called the central air controller. And so this is going to be integrated, it's still in its beta process, but it's going to be integrated for controlling the HVAC fan itself. So it will actually control the G terminal. It can control your dehumidifiers, your ERVs, and so forth, your filtration systems and stuff like that.
Excellent. I think that's going to be a major player starting later this year as to something that is not only able to monitor, but also control or increase your filtration. So I'm looking forward to that getting more integrated into the market.
Yeah, absolutely. And if you look at the screen here, what we have is a snapshot of what is called the Haven Pro portal. So this Zoet has been really good with designing this particular platform where you can access different devices that have been set up on your account as a contractor. and it'll flag things up. The main issue with this particular home is it's CO2 or it's PM. And so it'll be able to track, whether the fan is active, the PM and the VOC levels and stuff like that, and be able to flag things in your customer base.
Well, let's move on to your other device you've got. You've got a Katera Ag. Now, Katera is also in the commercial industry and does some common thing you may see and not even realize that is an air monitor. It looks like a security system or something, but these are their residential versions, and they have three. Why don't you describe what's out there and which one you have here?
Yes, I believe they have the Katera Origins, and then they have the Katera Laser Egg Plus chemical, which measures TVOCs, and then this one here depicted is the CO2. So it's the Laser Egg Plus CO2, which is the one that I'm familiar with. The reason I do CO2 is because I found that using carbon dioxide as a proxy for measuring and calculating the quality of the indoor air is more accurate because it's gas specific rather than a TVOC heated metal oxide sensor, which is cross sensitive to just about everything else in the air. So having
TVOC, it's
something,
hard to tell what that is. Was it a cleaning
right?
agent? Was it something in my furniture? But
VOC sensors, you can have a lot of fun with them. There are some devices that have VOC sensors that will respond semi-accurately, but the information is not really actionable or useful in the same way as the PM or CO2.
And as you can see, it's Wi-Fi connection, and it is integrated with the Apple HomeKit and works with IFTTT. So those are all things that, just like the Haven and its central air controller, it can be used to automate certain things, certain mechanical systems inside your home.
I refer to these as trend indicators, and
Yes.
they probably have a lifespan of maybe about 2 years before you probably maybe have exposed it to too much stuff, depending on the area. It could be a month if you're in a a nasty, dirty a shop. But in general, do you kind of feel like that's a general assessment as a time frame that you may want to think about upgrading this kind of device?
Yes, it has everything to do with the environment in which it's located, but generally speaking, 2 to 3 years is the lifespan of about a room air sensor. That is one of the cool things about the Haven, though, is that you can clean it. You can remove it on a maintenance and you can just brush it out. There is no internal fan. So there's nothing, and everything is pretty easily accessible. Just a cloth that go through that, the pathway of that sensor. It'll be easily cleaned.
Caleb, you provided a lot of great information today. I appreciate you coming, and we will catch up soon. And any last words you want to give to anybody listening?
I appreciate your time, and I think just ask questions, be curious, and learn more about indoor air quality because that is one of the most important parts of what we do.
Caleb, thanks a lot. Take care.
All right, you too.
So my next guest is Les Lazarek. Is that correct?
It is.
Okay. Les, why don't you introduce yourself and give us a little bit about your background and tell us what device you want to talk about.
Certainly. Thanks, Joe. So myself, Les, I'm based in Vegas since 1985. My background is mechanical engineering, where I focused on alternative energy design and have been full bore into the building performance environment since the late 2006, and got very involved with the state of Nevada in developing Energy Star, home performance for Energy Star programs here. And currently I do a lot of work on energy code development for the state, training, as well as a lot with both the ResNet and the BPI organizations. Appreciated Joe reaching out because he's been a great resource to me. And the product I'm talking about is the Yoo-Hoo device. And it all started when my wife and we renovated a new product or a new home, or a 2003 home we decided to renovate and move in. We wanted a one-story home. So I'm saying, well, let's set this up to use for training devices, for training as well. So on the recommendation I think previous individual you spoke to was Bill Spohn, who mentioned we were hearing some good things about this Yoo-Hoo device. So I went ahead and picked one up, and there were two rooms I was most interested in my home, my office and our master. And always the debate, listening to the different conversations from, Ian Walker and Brett Singer about the quality of these sensors that are in these devices. So what I ended up doing is getting one, watching the trends, realizing don't get set up and focused on the individual numbers. And then maybe about 7-8 months later, I picked up another model thinking, let me put them next to each other and see how they compare. Thinking maybe they're from slightly different batches and let's see how the sensors, and they really tracked each other really closely. So that gave me good confidence of the reliability or the consistency of the data.
Repeatability. Yeah. In fact,
The
you brought up
repeatability.
something. Yeah, I want to mention that is that I tell people never buy one device because you never know if it's drifted or something going on, or you have nothing to compare it to. But I have two, they should be relatively close. But and then one of them goes crazy, you now know, wait a minute, one of them has gone crazy. I may not know which one, but some good diagnostics can confirm this one needs to get recalibrated.
So from that standpoint, very good. What I find in my home, the two items that seem to get elevated on a more consistent basis are the CO2 and the NO2 are the ones that, based on the door configurations, people in the room. Now that we got another dog, we can see that tends to have an impact. Or if the heating or air conditioning is not running, we're not getting that mixture. I'm looking forward to maybe Joe doing this talk next year, because I want to collect data for about a year, and then we're going to be installing an HRV individually ducted throughout the house, and to see what is the real benefit and value in moving to an HRV. And that was really why I wanted this data. So as we're looking, I love the data. I like the consistency of the data. I think the app, both on whatever I'm looking on my phone or on a tablet, I think it displays the user interface is really useful. It's real easy to share. I've taken mine to different homes when I'm working on some indoor air quality, and we'll leave it at someone's home for a week or so and set it up so that they can see it as well, and we can talk about it over the phone. And clients really like that. I think from an aesthetic standpoint, it's not obtrusive and it's appealing. One feature I'd like to see that this product has is the ability to personally download data. There's Yahoo stores everything on their servers. It does seem like there is a way that they may support individuals if you want to get some data here and there, that they can supply that for you, but no guarantees there. But I certainly like to have more control over the data.
Well, Les, thank you so much for giving me your time today. A lot of things that I learned from are because you've sent forward me some emails or other stuff, or we have a good dialogue with, yourself and many others on, to learn more about what's going on besides the lack of conversations we get to have in person. So I appreciate all of your connectivity and connections and links, and thanks for being here. So, if there's anything else you want to throw out, go ahead.
I'm good. You guys enjoy the rest of the conference and keep learning.
Awesome. Thanks. We'll be in touch soon. I look forward to seeing you in person somehow, some way this year.
It'll happen, Joe. Take care.
You too. Some things we'll talk about are standards. Some standards, we'll talk about, Peter, the well or reset standard for a building. So you can get your building certified to be a well standard. It's a very common understanding right now. I think that eventually that'll creep down towards residential market, and we'll find that HERS raters will now also become somebody who certifies a home to be well or healthier. I do see that in the future of a HERS rater. There's also a standard called reset, and they also do something similar to what the well building standard does, except they use monitors specifically. And those monitors must be, you got it, reset certified. So if you're going to do a reset certified building, you must use sensors and devices that are reset certified. So you can see here on the bottom left that there are C grade consumer stuff which do not fit their criteria. There's B grade, and there's a criteria that they have to fit, and manufacturer says yes, they fit that. And they're all compared to a reference, which is A grade, which is what LBL and Brett Singer and everybody kind of uses in their labs to say, oh, here's what your device is doing. So you can have buy a device that actually is reset certified. Peter Trost will talk about his device, which is the only one on our show today that is a reset certified device. Most of you may have some of these, or you're trying to figure out which one to buy or which one to buy for your mom. So the Aware was one we just mentioned, right? And Peter Trost is he's going to talk about the fact that they have this device and how they use it. So Peter, why don't you introduce yourself?
Great. Thanks, Joe. Most of you know me as the head of Energy Circle, which is a marketing company for the home performance and HVAC world. But in today's example, we're talking about the Omni Aware or Aware Omni that we installed in our office in Portland, Maine.
Why did you decide on that one? I know we had some discussions about which one should you get and why. So why did you pick the Aware Omni?
It seemed like the right product for the price point. So the Aware Omni is their what they call their kind of business product. It's got these sensors, so temp, humidity, CO2, TVOCs, PM 2.5, light, and noise. And so it's got a good array of sensors. They're all individual sensors, no proxies. The price point was $399 plus $60 a year as a subscription fee. So I think of the more advanced products that have the good sensors, this one I think has got the best price point out there.
We also discussed, you've done some blogs. So I know you guys have things that are out there regularly about your office and why you've been doing this stuff, and especially when ventilation and COVID exploded, and how do you do 20 air changes per hour and weird stuff like that. But you also were looking for something that had some validity. So
Yeah.
you chose Reset. Many of those things you did, light and sound, are part of the building standard, but also Reset has a standard for the building as well as. Why don't you describe what you've learned about Reset for the devices?
Yeah, so we looked around, one of the things, and I'll just go to this particular slide. So we, looked at some standards out there, and we're trying to set a fairly high one for our building. We have the fortunate circumstance in which we did we guided the retrofit of our office space with our landlord, and we put in a very sophisticated Fujitsu VRF system with a Ventacity separately ducted HRV. So we have the advantage of a really good system that we can control, and we wanted to therefore set a pretty high standard. So we looked to the high performance version of the Reset standard. So where you can see what their standards are here, and so that was what we looked at as as a guideline to determine whether we were accomplishing a pretty high performance standard.
Well, to clarify, what we have on the screen is the certification for a commercial interior, as well as your devices are certified through the Reset standard. So the Omni Aware is a Reset device or certified device for Reset, and these are the parameters that you want to monitor and try and maintain.
Exactly. So
what kind of dashboard does it tell us, or what do we get from their units?
Yeah. So first of all, and I think you and I have had lots of conversations about this, about the validity of, like most of these devices, they come up with their own score. So, which is some mysterious compilation of the various things. It's a nice thing to see. It displays on the front of the device. But I think you and I are both of the mind that it's a little unclear what's in the black box to develop these scores. And so,
and we're talking about the AQI, to clarify, because the AQI, everybody has their own AQI as this magic number. Yeah,
exactly. So with when I ran, this is from earlier today, when I ran this, we're at an 88, and I can explain to you, it becomes pretty clear, but you get a sense here, and this is a snapshot at the point in time at which you're looking at it, where each one of the levels are, and what's penalizing us to an 88 at this point is humidity level of 21%. So that's the main driver at this point.
So we are on a tight time frame. So I just wanted to give you one last second to say, you were trying to make sure that your office, you're able to determine that you are in a healthy environment. Did you felt that now monitoring your conditions gave you that confidence that yes, you were successful?
Yeah, it does. I mean, I think we obviously took a lot of measures with a lot of support from professionals like you and the Ventacity folks in terms of making decisions about how to crank up the ventilation, right? So because it was originally set based on a kind of an energy efficiency goal, right? And so in addition to a health goal, so we made some decisions to turn that up a bit during the COVID time period. We've installed a number of HEPA filters around the office, and so we feel like we've actually replaced all the internal filters. The filter at the HRV is already MERV 13. We've replaced all the interior filters with MERV 13. So we've done kind of all the things that we could do. And what's beautiful about having a device to kind of keep, to tell us how we're doing is that it's a real measure of our performance. Obviously, using CO2 primarily as the core proxy for the question of whether we are ventilating sufficiently should the virus get into the building with somebody coming in. Are we taking care to see that it does not remain in the air? So it's felt good. We've made it absolutely public. We've been doing some hiring recently, and we've made the data public to prospective staff, and I think people have been pretty impressed about it.
Well, we look forward to an updated blog when you are back to full staff and to see how well these numbers are doing and to see what occupancy can be a challenge with making sure that you have a safe environment for everybody.
You will get it.
Well, Peter, I want to thank you for being here today, and we will have other guests. They're going to complement what Peter is talking about and how everybody's using these differently. So again, thank you again for being here, Peter.
Thanks for having me, Joe.
All right, so we've had a lot of great people talking about individual devices. Most of them are using one, some are using two, and able to compare them. They've shared some of their challenges between multiple devices. But if you really want to get accurate information, it is best to have devices that are specific to that. And one person who has been a major leader, I refer to the grandmother of IAQ devices, is Linda Wigington. She's going to tell us about what she's done in the industry and some of the challenges that go along with just one device. So Linda, why don't you introduce yourself and talk about your organization?
Yeah, my name is Linda Wigington. I'm team leader for RACUS. RACUS stands for Reducing Outdoor Contaminants in Indoor Spaces. And we started 6 years ago, but 5 years ago we began, or 5.5 years ago, we began our exploration into low-cost monitoring. And our initial primary interest was looking at the difference between outdoor and indoor with a focus on particles. But it was very clear that you can't just look at one dimension of air quality, particularly if the dimension of air quality you're looking at could cause you to tell someone, well, to protect yourself from dirty outdoor air, you should close all your windows. Well, you better not do that unless you have some idea of some pollution sources inside, particularly radon, and just what's going on with kitchen range hood and other sources, CO2. So anyway, that's why we ended up with a constellation of monitors in our project. We basically give folks a kit. We invite people to participate in a cohort. A cohort lasts 3 to 4 weeks, typically 10 to 15 folks. Used to be just folks from Southwestern Pennsylvania, but now we include some folks from outside because it's virtual. And we direct them on how to use the equipment, and we provide log sheets and directions for giving us the data. And we give them weekly feedback. And they basically get 3 Dylos monitors. The Dylos would be this monitor. And 1 outside, 2 inside, because we're trying to see the difference inside. We also want to see the very specific impact inside and outside.
And the Dylos is measuring what type of particles, or what was it measuring?
Yeah, Dylos is measuring particles. What we liked a lot about it was that 5 years ago, there were just emerging low-cost monitors, but most of them were looking at a micron range of 2 to 4, and we really wanted to be able to see smaller micron size cut. So the Dylos measures 0.5 micron and above. It also gives you a cut that's 2.5 and above. But what we found by using a couple different monitors, that the 2 to 4 range size just didn't see the air pollution. I mean, it might see something that's incredibly local, like somebody putting up hay in your backyard or mowing grass, but it did not see the ambient or air quality. And we had much better, we wanted to answer the question, when should people open their windows? And we couldn't tell that without having an ability to see 0.5, the smaller size particles.
Now, 0.5, I have a slide that was already in this video, including about how small those things get, and that's what's going deep into your lungs, and that's why it's important to understand those, because the larger stuff can get caught before it even gets deep into your lungs. So most monitors are not doing that type of analytics. Even 0.1 is some of the things that can be caught, but in general, most are giving me 2 and 2.5 and higher. So it's good to know, but I really want to know more about the smaller particles.
Yep, and also with interventions, we want to know how well an air cleaner is working and maybe when you should turn it off. And if the only thing you've got is telling you large particles, it's going to tell you the air is clean before the air is clean. In fact, I'm sure if we strictly went by what the 0.5 reading is, we'd shut off an air cleaner or filtration system prematurely because we're not seeing the 0.1, and you want to run it longer. The smaller the stuff is, the longer it hangs out in the air. So it'd be great if there were even smaller. Well, the purple air does measure 0.3, but I wouldn't consider using something that doesn't measure at least to 0.5.
You are a wealth of information, and you inspire a lot of us, Linda. I just want to say thank you again for being here today, and all that you do for our industry, and so many other people that have taken your research and actually put it into practice. So thank you again for being here.
Sure thing. Thanks for inviting me.
I look forward to seeing you in person soon. So take care.
Okay. Bye-bye.
I was lucky enough to track down Brett Singer, who gave me some time to confirm many of the statements that I've been making and others about these consumer grade indoor air quality trend indicator devices. So Brett, why don't you tell us briefly about where you work and what do you do, and then I'll ask you some questions.
Great. Well, thanks, Joe. It's fun to be here. I work at Lawrence Berkeley National Laboratory, which is in Berkeley, California. I work in a group that does both indoor air quality and energy efficiency. We do a lot of focus on residential. We do some commercial work as well. A lot of you know Ian Walker, who's a close colleague. We get our funding predominantly from the Building America program from the Department of Energy Building Technologies Office. So if you find that what we do is helpful, support your DOE, tell your congressman that's good money spent to promote America. And we do research to support healthy, efficient homes.
So we've had lots of discussions, which I'm going to try to summarize here briefly. That I think we both think that these consumer devices have some positive applicable things to do for folks. We believe they're trend indicators, but there are some things that are actually growing in terms of better sensors. Can you talk about what you would describe as the things that are doing well and things that are not doing well with the sensor technology?
Sure, and I would actually argue they're better than just trend indicators. I would argue they're incredibly powerful, useful devices that are now accessible to a lot of people, if not everybody, for a ballpark $200 plus or minus a bit. You can get a sensor that will give you a indicator or will inform you when you have high particulate matter concentrations in your home, or when you have high carbon dioxide concentrations in your home, semi-quantitatively. The reason why I don't say fully quantitatively is that for each of the sensors, there are some limitations that people need to be aware of. But there's certainly the information, if you pick the right device with good sensors that are available, the information you get is plenty good enough for you to take action to manage your indoor air quality at home.
Would you make the statement that carbon dioxide and PM measurements for many of these sensors are considered to be accurate enough that they are close to a B grade device?
Right. So thanks. And I was going to go on earlier, but I wanted to give a pause there. So to follow the talking about those two sensors, carbon dioxide and PM2.5, specifically with carbon dioxide, the most important thing is to make sure there actually is a carbon dioxide sensor. Early on, there were some devices that claimed to give a carbon dioxide reading that was CO2 equivalent, and they were using a low-cost VOC sensor that also responds to CO2 to give you a CO2 value. The problem is that if there were also VOCs, it would not give you an accurate reading, and they were not very accurate for CO2. So avoid sensors that say CO2 equivalent. Make sure there isn't actually a CO2 sensor. The two sensors that we most commonly recommend is to make sure to have a carbon dioxide sensor for ventilation and a PM sensor, so you could have a sense of when there are high PM2.5 levels in your house, because that's probably the most important air pollutant for your health. Starting with the CO2, the main thing you're trying to figure out is if you basically have adequate ventilation or not, or if there are periods where it's poorly ventilated. A good benchmark value is 1,000 ppm. Devices that actually have a CO2 sensor, which is critical, make sure it has a CO2 sensor and not a CO2 equivalent value, which comes from a VOC sensor. So have a CO2 sensor, and that CO2 sensor will help you distinguish whether you are ever substantially above that 1,000 ppm cut point or threshold or reference that we use as an indicator of adequate ventilation. If you're always at 1,000, you might want to ventilate a little more. If you're occasionally getting to 1,000 or 1,100, that's fine, especially have a party. Overnight in your bedroom, some people like to be cozy, a little bit higher CO2 in your bedroom is fine. If you're getting up to 2,000 or 3,000, you probably want to ventilate a little more. So those low-cost CO2 sensors are good for that, to tell you approximately where you are, which you wouldn't know otherwise. The PM2.5 sensor, you're mainly looking for two things. You're looking for whether you're keeping the inside of your house clean when there's high outdoor PM2.5. And the biggest example of that for most people in the US is wildfires. We do occasionally have places that have a high PM2.5 from wood smoke, but the really, really big threat is wildfire smoke. So it helps you figure out, are you adequately cleaning the air inside your house to protect you from those high levels of wildfire smoke? Not all cooking causes high PM, and some cooking causes crazy high PM. We always recommend people to use the range hood, but the question is your range hood effective enough? These low-cost sensors will tell you that information. If you're cooking, you turn on your range hood and you're still getting 40, 50, 60, 100 microgram per meter cubed of PM2.5 on your low-cost monitor, you know that your range hood is not effective enough. And that could be that it's the hood, it could be how you're using it, it could be you're cooking on the front burner instead of the back burner. But it tells you the important information that what you're doing is not good enough. You should do better. You should find a better fix. There are good sensors out there. There are devices that use these good sensors. Not every device that's available for purchase uses valid or validated sensors. So some homework is required. I'm going to give you a link, and Joe will share with you about a paper that's public access or open access that some colleagues in Europe, where they tested a collection of both sensors and devices that measure PM2.5 and CO2. They report results so you can see and look for the specific sensors that they tested or the devices. You can definitely get a good device to do CO2 and PM2.5 for as little as $150. I know of one device. And certainly there are several devices for under $300 that do both of those accurately. But if you're under $100, I would be very cautious. I have not seen anything for under 150. And you do need to check to make sure that the device you buy has sensors that have been validated in some way, shape, or form by a third party.
Brett, that was almost an entire session in itself. So you are a wealth of information, and I know I only got a fraction of it. So thank you for your time today, and I'll use most of your video throughout my presentation. So I look forward to seeing you sometime soon in the future, physically, somewhere, somehow. So thanks again for your time today.
Hey, thank you, Joe. And for all the people out there, I gotta tell you, I really miss seeing you at the ResNet conference. And I hope next year we're all there together. Take care.
Thanks. See you soon. Take care. Thanks a lot.
One of the things that is happening, because clearly you're a hertz rater, you're maybe a builder, a contractor, and you're listening to me go on and on about these devices, but how do they impact you? So this is actually a show home that we had at the EVA conference back in 2019. It had actually had this type of system already integrated, and we set up something in the kitchen to show that when particulates are high or VOCs are high, that you can actually have your exhaust fan or a variety of other exhaust fans in the house come on automatically and kick on to alleviate those conditions. This is the future of our buildings. This is where we're headed. This is not unthinkable. It wasn't that long, probably long ago, that your grandfather was like, thermostat, who needs a thermostat? Just turn the dang thing on and off. So uh, home integration, smart homes are now here. We're just now learning how to make these devices become much more, not just intelligent, but invisible, that they will be able to help us ventilate the house and control our particulates and make sure that our carbon dioxide levels are low. So, pardon me. It's headed for a home near you, or probably in one of the homes you'll be building, because your occupants are now and buyers are asking for it, because COVID reminded them that living in my house more than I used to is not healthy and sucks. So I want to find out, how do I make my indoor environment better? Well, here it is. It's coming your way. Indoor Air Plus version 2 is coming. You can actually go online right now and give your comments. Their goal was to try and figure out how to get smarter readings, more information about what's being built using indoor air quality monitors. I think that there's going to be a major learning curve for them and everybody who's going to try and do this. I applaud them for doing it. Way to go, Aaron and Nick and the whole team, for trying to make this something that we need already in our industry. So what it's saying is they think indoor air quality monitors will be integrated to confirm certain compliance conditions. They are already going out with combustion pollutant section 5.1 combustion appliances, that you would need a device that actually is telling me if my particle count is above or my carbon dioxide is high. I think the carbon dioxide number is going to be a challenge for you. So we'll see what happens. But in general, they have a variety of advisory. And we know what advisory means. Advisory means that version 3 or 2.5 probably means these are things that they want to be integrating, or they give you options. Usually there's a trade-off. Like if you do this, you don't have to do that. So maybe we'll see what kind of conditions come along with that. So again, these devices are going to be integrated into homes that we are uh, certifying, rating, building, living in. It's now going to be something that we just live with. You can only control if you measure the conditions. If you measure the conditions, you can control the conditions. A lot of things we talk about are only measuring. I only am gathering data. I'm really not doing anything with it. We mentioned what was happening at some of the houses that we saw at EVA, but in general, all the devices so far have been like, I'm monitoring. That's great. I know now I need to figure out, what am I doing? Am I opening windows or doors or changing my habits, showering less? But pardon me. In general, we want to have devices that actually do something. A lot of the air purifiers are headed this way. In the extended version, Brett and I had a conversation about these devices. He's very excited about it. I am too. One of the things to be cautious and conscious of is that usually where the device is cleaning the air and making it good, usually has good readings. So it's kind of a challenge. Like, the other side of the room has got high particulates, but by the purifier, clearly it's not, because it's the air purifier. So one of the challenges is that, can I actually determine what's going on in the room away from the monitor? So that's the goal, is can I get another device somewhere else in the room that says, oh, we need to clean this room, not just what is at the device. These are the newest things that are going to happen. I really think that Broen and Panasonic are going to change the game, because we're all dying to figure out, how do we do ventilation? How do we do ventilation well? Panasonic, Broen, Zender, they all make these amazing systems that are whole house systems. They may integrate with your existing heating and cooling system, but in general, we really need to focus on, what can I do about smart ventilation? Smart ventilation is trying to do areas of ventilation that actually can encompass the whole house. So when I have a high moisture event in the bathroom, can I actually exhaust from there and supply to the kitchen, or supply from another part of the house? So the concept here is that I have multiple fans that are able to do multiple things. So clearly, the exhaust fan takes out, but there's somewhere you have supply fan or fans that are actually able to bring air in. So you get technically a balanced ventilation system that actually is able to give supply and return more parts of the house with multiple sensors throughout the house. So there's the system that's here says, okay, if one system sensor indicates something, I can actually program it to do whatever I want. When I see high particulates in the kitchen, I want the kitchen fan to clearly rev up, and I also want my bathroom fans to also come on to 30% or that kind of program. So they give you the ability to do an amazing control system. And these are really coming out this year. I'm allowed to kind of talk about it because they said, okay, they were at the IBS show and others. You may have seen this live action. So it is coming to a home near you. And they also integrate with their ERV, which is a great option. So you can see their concept is, multiple devices, multiple systems in the house working together. And Panasonic has actually got it out right now. So the Cosmos is designed to actually have a central hub with an air quality monitor or multiple air quality monitors. I told them they should have more than one. And then it works with an app and a central system that says, okay, I can now kick on my exhaust fan, my kitchen exhaust fan, supply ventilation. All these things are now working together. And yes, you may notice that the shape of their air quality monitor looks like the Fubot, is because that's one of the things they were able to integrate quickly is the Fubot. I can tell you off the record that they are working to completely upgrade this type of device so it actually has a direct CO and other better sensors. Everybody's working constantly about like, okay, this is my last year device. This year we'll have these sensors and they're better than last year. So look for that as a constant upgrade for a variety of these kind of conditions. You're going to be swapping out sensors because they're being much better and actually much more available at a cheaper price. All right, so we've seen a lot of great information so far and heard from a lot of people about individual devices that just monitor what we're actually getting, right? There's also another one out there that not just monitors well, has great sensors, but also is an ERV, also a conditioning unit, and can rebalance with the air throughout your house. So I brought Bill Spohn on today to talk about that. He has one in his house. And Bill, why don't you tell us about what you've got and what you want to cover today?
Sure. Thanks, Joe, for the opportunity to do this. Yeah, this is a Serve 2, a conditioning ERV, which you're looking at in the screen right now. It's installed in the basement of my new high performance house. It basically conditions the air from outside as it's functioning as an ERV. But it's a smart ERV or maybe an integrated ventilation appliance, you want to call it. And they've chosen sensors that are specific for this use case. So it's designed not to be an analytical VOC system, but to trigger when VOCs reach above a certain threshold and then provide the ventilation. So let me advance the slide here. So CERV, conditioning ERV, it's got built into it a 1/3 of a ton heat pump. Should have shown a picture there of it kind of dissected. When you take the covers off, you can see the compressor in there actually. It has MERV 13 filters in both airstreams, and that would be the airstream exiting to the house and the airstream coming in from outside. So it's sort of double filtered if you want to think of it that way. I think it's pretty smart because it does a number of things that are mentioned here. It assesses the air quality. It does actually have sensors built into it, so it knows what's happening in the stream of air that's providing to the house. So you can set, and I'll show you in a couple of seconds here, couple minutes, the actual output of a live control, and I'll actually give you access to see my serve in action. You can dial in view only all the data that we have going here. So it does a recirculation mode, which is a programmed recirculation. You can set it up for whatever interval you want, sort of like when you stir the air in the house, maybe with a conventional HVAC system and move the distribution air around. It also, the assessment that might lead to a ventilation mode, where it would then attempt to ventilate and to reach the threshold below which you wish to operate the system at. It brings in, of course, brings in fresh air. And I think another aspect, it brings in the fresh air, but the outdoor air is also conditioned. It gets filtered for particulates through a MERV 13 filter, and it also is conditioned with the energy coming out of the exhaust air. So if we're in heating mode and we're pumping out exhaust airs, say at 67 or 70 degrees Fahrenheit, that heat is going to be captured by the heat pump and transferred over to the indoor airstream. And there's actually a way to set up the set points of temperature at which you want it to bring in the outside air. Do I want it to bring it in if it's 20 degrees outside? I like to try to get it to 67 or so I'm not blasting cold air into the house. This is an idea of what's happening in the data. There's a portal. There's also an app which basically accesses the website, so I can get real-time control on it from anywhere. It allows me to assess the pollutants versus standards, which I think is very unique. This is also something I'll show you real time, but it will tell me how I'm performing. So it gives me a performance graph against various standards, like what the manufacturer prefers is the range, what ASHRAE prefers, what a poor IAQ range is. And this would be like CO2 hours versus VOC hours per day, and it puts me on different graphs. All right, so this is live information here. And this mimics the display on the unit. There's an LCD touchscreen on the unit that looks just like this. So this is as of February 5th at 12:39 p.m. And that's either delayed data or they're using their time zone from Illinois. I'm not sure which. But so this is the control, and I can actually affect control from here. So I can do things like change the fan ECM settings. I can change the operation mode from auto, just do what the sensors tell it to do or what I've set up programmed. I could turn it to vent only. And if I choose vent only, I can choose whether it's heating or cooling. But we are getting better sleep quality because we have the CO2 level maintained below 800 ppm. And the cognition quality, I think that's a hybrid between their determination between VOCs and CO2. This is the exposure this week, and I can change the time frame however I want. But I think this hybrid graph is very interesting to let you know how far away you are from the bullseye where you want to be. Anybody wants to take this down, buildequinox.com/service with a C. Use, in place of the email field, put in this code 766902, and then the password is demo. And then you'll be able to see my system and look at the historical data and look at the control set points, although you won't be able to adjust my controls.
That was a overload of great information, Bill. I can't thank you enough for everything you do for our industry. So thanks again, and I look forward to having you back again soon to do something similar.
Absolutely. You can look forward to having Overkill Bill anytime.
So you heard from a lot of folks today talk about their individual devices, and some others talking about how they interact, and some things we've learned from LBO Labs. But what really matters is the health impact that we're trying to monitor and what those mean. So I have Kevin Kennedy as my guest. So Kevin, why don't you introduce yourself and talk about some of the things you think are important that people understand about these low-cost IAQ monitors?
Well, thank you very much for having me, Joe. Obviously, you and I have had the good fortune of working together for many years, presenting on various topics. I'm the director of the Environmental Health Program at Children's Mercy Hospital in Kansas City, where for just about 20 years, I've run a program that goes to homes, schools, child cares. We investigate and evaluate potential risks of exposure to various indoor environmental conditions. We do a lot of investigation of indoor air risks. So we do a lot of measuring, a lot of sample collection in those environments, trying to assess and characterize the potential for a child in particular to be exposed to something that could be resulting in either a health problem or contributing to a health problem. Many of our patients have allergies or asthma or are complex medical in that they are immunocompromised or immunosuppressed. So there are particular indoor conditions that they are extremely vulnerable to. So we have some experience in trying to measure and quantify certain kinds of risks and have played around with some of the things we're talking about.
Let me start off with one question that I didn't really dig into very much, and that is that how long do you think one of these devices should be in a room for even a homeowner to determine that they've got some accurate data, and where should they be putting some of these devices and maybe moving them around to?
Yeah, it's a great point, and one that I have emphasized the first, of course, being, how accurate and precise is the device in the first place would be the fundamental question. And then that is one of the fundamental limitations is I have one instrument that's measuring and providing some data. Well, what does that represent? Does it represent the whole building? Probably not. It's likely going to represent the room it's in and what contributes to the airflow, the circulation, the distribution in that individual space, and how representative is that of what somebody might be exposed to. The other thing to be thinking about if you're collecting this data is what kind of evidence, if any, supports what you're trying to measure and quantify. Is there research evidence to suggest the collection of that data is representative of a exposure? There's a lot of research evidence that doesn't show a direct connection to measurement. So it's important maybe to think about the length of time you might be measuring it. And 10 minutes in an environment just isn't sufficient for the vast majority of parameters you might measure. Now, you might think of something like carbon monoxide, where if I have a carbon monoxide detector that I carry around or I have on my belt as a measuring ambient CO, that at least gives me a characterization of the whether there's any carbon monoxide present. But if you think about something like particles or carbon dioxide, those things might be slightly variable from space to space. And in particular, particles, there's lots of research evidence to show that we're all personal pollutant cloud generators. And everywhere you go, every surface you touch, there is an amount of breathable settled dust that when you come in contact with those surfaces or even shaking your shirt, you generate an amount of breathable particles into the air. And you might see that on one of these monitors in one space next to the monitor. So collecting data for a few minutes isn't going to be representative. And I would even suggest collecting it for a few hours may not be representative. If you're really trying to understand the exposure, you probably want to do it over a typical day or maybe even a week so that the different activities, behaviors, and practices that the family's going through or the person's going through in a given time all is shown on there, and you get an idea of the patterns of behavior and the activities that might be contributing to potential exposure to something like breathable particles.
I tell a lot of folks that only have one unit that they should try to put it in their bedroom, kitchen, living area, places their office for 2 to 3 days and kind of get let it balance out. Make sure you're active in those rooms. Do you agree with that kind of assessment for one device?
Yeah, I think if you're going to use one device, or if you have a consumer that you're working with and they have one device, absolutely encourage them to move it around. And just as you said, don't keep it for a short time span in that one space, say 4 hours in my bedroom. No, have it there for 2 or 3 days. Get a pattern of how these things change, how each of these potential measurement parameters, the contaminants they might represent, how they might change over time. Because I think probably most of your guests, or many of them probably talked about, one value to these devices is the trends that they can show, because you're getting a large set of data and you can look at how that data is changing over time. But that means you need to do it over the period of time that represents the normal activity in the home. And a key concept for health scientists would be if I'm going to try to assess exposure, how much of the time that instrument represents my actual exposure time. I wanted to characterize the actual exposure. If I'm doing it for 10 minutes, a half hour, 2 hours, 4 hours, that isn't truly representative of exposure. Whereas if I do like you had just said, move it around, keep it in a location for 3, 4, 5 days, then I'm getting different ideas of what kind of potential exposure occurs in individual spaces. What you've heard us advocate for, what we're doing at Children's Mercy, is actually deploying 3 of the devices minimum, and we're looking to deploy even more, having those in a space for maybe 24 hours. So if I've got 6 devices deployed for 24 hours across an entire space, I can see how all of these parameters are changing across the whole space. If I do that for a week, I've got really good information about airflow, about potential outside air infiltration, about pressure differentials, about exposure pathways, because that's what our primary concern is. Are there points sources of some kind of pollutant, like say a stove generating carbon dioxide? And then how does that emanate through the space? Can I describe how the air movement that carries those things into different spaces? And then finally, the individual spaces have their own potential sources, especially for particles of dust. So if I can look at that across the space, then I have a defensible way to say, looking across your space, these areas were of lower risk, but this particular part of your house seems to have elevated contaminants, whatever I'm looking for, that may be associated with the time you spent in that space and ultimately uh, uh, be a concern related to health. But I want to reiterate that there is little to no evidence to make a direct causal link between what is measured and what health problems somebody's reporting. I can't go into someone's house, set up a monitor, come back a day later and say, oh, this is causing your health problem, unless it's something like carbon monoxide, where it is high enough that anyone exposed to that level of carbon monoxide is going to have those physical symptoms they're reporting. And that's called a building related illness. And there's lots of evidence to show that investigators can identify those very specifically.
So let's kind of wipe out everything that I've talked about with all of my guests, including what you just said, and the fact that it's great to be monitoring anywhere for any amount of length of time. But if I don't have a visual assessment of what I'm monitoring, even from the homeowner who's there can do that. But if you are a builder and you want to find out why this person's complaining about their child having asthma and you put a monitor in someplace, if you don't go through and actually evaluate and find out that they've got stuffy toys everywhere in the house, or they've got a variety of conditions that are causing these levels to be up, why don't you give us your great understanding as to why the visual assessment supersedes anything that we're gathering with our instruments?
Oh, heck, I don't need to talk. You said it well. Uh, the, because fundamentally, all of the research evidence for 30 years, whether it's measurements collected like these air monitors in real time, whether it's measurements collected by a professional, whether it is samples collected by a professional, all of that information is of little value if it is not used to support a systematic visual assessment done by a trained professional, and it is used to support a hypothesis that might have been developed by that trained professional. You need someone with the expertise, the building science knowledge, some environmental knowledge, some knowledge of indoor air quality science and the parameters that we're investigating. They have to have that base knowledge. And I would say 80 and almost 90% of the assessments performed in homes, the visual assessment is really going to be what drives what recommendations are made. The data you might collect is to inform the visual assessment, to inform the hypothesis, so that you can determine conclusively what you think, as much as possible, are the reasons for the environmental conditions you're seeing, and that makes it easier to draft recommendations for how to address those environmental conditions, reduce the potential sources of environmental exposures, and ultimately, you believe that that will lead to better health.
Great answer. So you definitely elaborated on what I put as a premise. So two other questions for you, and one of which is that let's assume that somebody did their homework. They found out that they did get a good device. They liked the information. It has sensors that we consider to be consumer accurate. What kind of information would you try to tell somebody about, okay, now that you've got this? We talked about how to do it for several days. Let's talk about some of their behaviors. Can you give advice as to, like, okay, when you see, let's say, high PM as a concept, what should they be looking for as a condition? We'll exclude the kitchen as this concept because we know that's a direct evidence there. So if I say, wow, my bedroom for some reason has high PM, what could be causing that kind of condition?
Well, there's That's an interesting question, because if someone is set up the monitor in their bedroom and they see that the particulate matter is going up, they set it up, it's stabilized, and they're seeing particulate matter go up. There are a couple things they need to think about. One, first, the room itself. Let's look at all of the components of the room. What's the furniture? What other components are in there? Is there carpeting? Are there upholstered surfaces? Are there other upholstered items, pillows, stuffed animals, other kinds
Bedding, yeah.
of bedding, other kinds of surfaces that can collect and hold on to dust and settled particles? Any agitation or disturbance of any of those spaces kicks those particles in the air. And our own work has shown that they actually do stratify a little bit by breathing zone, so that larger particles don't stay in the air very long. Finer particles tend to stay in the air much longer, and ultrafine even longer. So if I'm looking at a device that's looking at PM2.5, that can be readily aerosolized and distributed around the house, and it comes from people disturbing surfaces. That's one potential source of those disturbed surfaces. And then the other would be airflow into the room, whether it's coming through the vents, whether it's coming through leakage, or whether it's coming through the doorway as I walk in. I create an air current just by walking into a space. So I can actually, just by routine walking in from a high particle source into a low particle area, I could be pulling particles in. The clothes I'm wearing can have enough particles on them that I could actually pick that up conceivably on a monitor after I've taken them off and maybe set them on a bed or something like that. So the other source is this potential circulation itself that's led by pressure differentials or air infiltration. So the actions I might recommend to my client based on what I'm seeing and the potential behavior, if they give me that data, I can advocate to them that to reduce settled dust, I might do more regular vacuuming. To reduce settled dust, I might use a higher efficiency filter, and I may have to have the cycle of the air handling unit in the on position for a period of time so that I've got regular airflow. I might recommend a portable room air purifier. I might recommend air sealing because of the amount of air filtration I'm seeing. So there's a lot of things I might be able to recommend based on what that data is starting to tell me. But you pointed to an important point about this. And it isn't just that I have the measurement data and say, oh, look, this data says you've got something high. It's what was going on at the time that data showed up. If I've got a spike in some of the data, what was happening? So if you're working with a client with these monitors, you really have to ask them to maintain some kind of log or diary or notes on their phone or whatever it is about the just daily behaviors. And the research shows that is very hard for clients to do. Most of
But even
us
for
who have,
homeowners, yeah, they realize that I just changed all my bedding, and 5 minutes later was the spike. Things are not instantaneous on the
that's
devices
right.
either.
That's
So they were like,
exactly right.
"What just happened 5 minutes ago?" And they're like,
Yes.
"Oh yeah." So but sometimes they don't look at the data till 2 days later. They're like, "Oh, I finally look at my device, and what did I do
And
on
they
noon
don't
on
remember
Saturday?"
exactly.
Yeah,
And
right.
that's a common problem in people who do this kind of research. And when we've done this research, we've had people try to maintain a diary. We've done cleaning studies, and it's really hard to get the research subjects or clients, families to be able to track that as it happens. They might have a pretty good recall, but most people don't.
Right, so this will probably not, this will only be in the long version, but what you just talked about was that particles, large and small, that has been a common thing that the average occupant now is aware of because of the COVID conditions, aerosolizing, what we're breathing. All this stuff has now become something that's a regular discussion, and people have been informing themselves through either Twitter. So let's elaborate briefly on the fact that you just talked about these particulates that can fall sooner. I want to not go into the logistics, but more about the scare tactics that people are using, thinking that your device or some little magic thing in your house could be eliminating COVID. So why don't you give some advice as to really what's sound advice about this versus just saying like your PM levels are high means you could have COVID in your house is the kind of scare tactics I've seen out there.
Yeah, well, that's really problematic because I would be hard pressed to say that anyone has developed enough research evidence at this point to show a strong correlation between the particle counts picked up on a consumer air monitor and how strongly that might be associated with available virus aerosols in the air, or even bioaerosols. There really isn't any sufficient data that I have seen. It may be out there, but I have not seen any research that shows that kind of connection. There is some evidence to suggest that for larger particles, when you're getting up above 2.5 micron, 5 micron, 10 micron, 20 micron, larger particles that can be part of the settled dust, people agitate that the allergens are often found in those larger particles, dust mites, fragments from mold, pet allergen from the dander, mouse
Cockroach
or
droppings.
rodent allergens,
Yeah.
cockroach. Well, it's going to be the allergens in the
Yes.
droppings,
Right.
in the exoskeleton, things that get crushed up. And some of the science on mold, for example, says it's not just the mold spores, it's the crushed organismal fragments, that the ultrafine components that get smashed into the general dust and debris of the house. And if there's no routine cleaning to remove that or reduce the amount of it that builds up over time, then that's what people can potentially be exposed to. That's in that higher particle range oftentimes. And that's what also has the potential for settling out quickly based on mass alone, is that it can settle out and people aren't actually being exposed to it. The other part of that is that the breathing zone of a child is different from the breathing zone of an adult. And some of those particles that might be agitated and aerosolized, the larger fragment, are going to be down in the lower zone, breathing zone of a child, as opposed to being in that of adult, depending on how much dust they're kicking through and how much of that gets agitated and elevated into the air and then falls back down again.
Okay, so let's finish off on the medical impacts of things that are in your dust that show up as PM particular, and some VOCs. Carbon dioxide, that's a common thing that, it can make you foggy and fuzzy thinking and cognitive impairment. But let's go to the other two that actually have been known to cause more conditions, especially PM and the VOC. So why don't you talk about some of the things that those things can cause for an occupant? Some people are more sensitive than others, but what some of your evidence show us?
Well, pretty clearly with particulate matter, you've got two, you have to think about all of these based on the person and what their vulnerabilities are. Uh, are the effects acute effects or are they chronic effects? Because some people exposed to an irritant can have an immediate reaction, whereas some people exposed to a low concentration of an allergen like dust mite or mold might have symptoms over time because they're allergic to it. And if there's a low level available in the particles, then they're being exposed to that a tiny amount over time, they may have just sort of constant allergy symptoms. So it depends on how much of it is in the air, and then what their potential reaction to it is. If it's allergy, it's going to be a little bit unique with each individual. So with particles, you're looking mostly at then the allergens and then the potential for certain chemical residues to be adhered to a particle. So you're going to have biological particles and then some potential physical particles that people might be exposed to that have maybe chemicals on the particle itself. That's one of the ways people are exposed to pesticides, is that the pesticides, the residues stick to the dust that's on the floor, and then that gets aerosolized, and people ultimately, through either hand-to-mouth action for children or just breathing, they might ultimately be exposed to some over time. For the VOCs, now that's generated by
Wait, I want to pause. So some of the stuff that I've sent on EPA was about heart conditions, not just
oh,
reduced lung capacity. So
okay,
yeah,
well,
there are some other physical things, if you could
oh,
confirm that
sure.
the evidence is out there. Sure.
Well, then the other really important thing related to particulate matter is, and this is really interesting, people tend to focus on the respiratory side when they think about outside air pollution, think about indoor air pollution and particulate matter 2.5 and smaller. They think about it from a respiratory and an effect on the lungs. But actually, the research is very robust in indicating the cardiovascular effects, that it actually is one of the major contributors to heart disease, is actually being exposed to these fine particulate, whatever the different types of pollution sources are. But primarily, a lot of that are combustion byproducts, and they are fine particles, even carbon particles that have chemical residues from just the combustion process or from smoking, the residues that make a fine or ultrafine particle from smoking. It's the effect of those, not just the respiratory effect, not just the cancer effect, the toxic effect, but there's actually a cardiovascular effect, and it's a very serious one that EPA is paying a heck of a lot more attention to now.
Right, excellent. So how about VOCs? I know there's, headaches are the most common one, but what are some other impacts that VOCs can have on some sensitive and non-sensitive people?
So the other big one that you've mentioned is the VOCs, or volatile organic compounds, and that's a wide class of compounds that can be volatile, meaning they have a boiling point at room temperature, so they readily become a gas. There are also semi-volatiles, depending on what the room temperature, that become a gas at room temperature, and some of these are cancer-causing agents. Some of them are, for a few people, they actually can be potential allergens, so they have an immune response to them. And then some of them, we don't know the health effects. They haven't been fully studied. And depending on the number and type and combination we're exposed to, they can contribute to all sorts of different types of health effects, whether it's a specific immune response or whether it's a long-term toxic effect of being exposed to it over long periods of time. Those are the chronic health effects for a lot of people. And one of the earlier indicators that the evidence suggests is people have headaches, people have irritation, upper airway irritation, they have sinus problems, they have bronchitis or upper or lower airway congestion, and that's from breathing in a whole lot of these chemicals, because they're using a lot of air fresheners, or they're using a lot of products that have VOCs in them. So there are different mechanisms and different ways that these different chemicals can affect people as they're exposed to them. And so many consumers don't even think about these as potential health risks. They think about, oh, it's a fragrance and it smells good and I like it. They don't think about the potential of breathing that over a long period of time and what kind of impact it can have. I should also mention, you have to be very careful about these air monitors and how they measure VOCs. Many of them aren't necessarily measuring and quantifying all of the potential VOCs in the air. So you can't assume that the VOC value that it's showing with some of these monitors truly represents all of the potential VOCs that someone is being exposed to in the indoor air. There are other techniques or tests that are going to be a little more comprehensive and specific.
Well, the one challenge with VOCs is that PM, I know it's particles. Carbon dioxide, I know what it is, but VOCs, it could be a dozen things. That it could be your own cologne and deodorant, let alone what's around you, or the candle, or your carpet, or unfortunately maybe what the house is made out of.
Off gassing off of everything in the house. It can be, one of, 1,000 different things, or all of those 1,000 different things, all mixing together. And the other potential there is if you have maybe some ozone because of dry conditions, plus this soup of chemicals, you're going to get new chemical reactions that lead to additional chemicals that maybe weren't the original source from a building material, but now because of these atmospheric chemical reactions inside the home, you've got new compounds you're being exposed to. Add to that the biofilms on surfaces that might be reacting or be involved in this chemical reaction with those VOCs and with potential ozone and moisture, and who knows what you're creating. And that's why more science might be needed. And you got to be very careful about making conclusive statements from a consumer-based air monitor.
I will give a link to the Home Kim, which actually does a great job of explaining
great
many of the
example.
things that Kevin just, so, but I just want to clarify that briefly, the biofilm isn't just like this thing that shows up on your kitchen countertop, that this is something that is on surfaces, period, no matter what, where, ceiling, walls, floor. These are just things that are come off of us, come off your environment, come off your cleaning stuff, and doesn't just evaporate. They go someplace and want to hang out until they're, called to come back into play in the room.
Exactly right. This is all part of our newer science, our newer understanding of a complex microecology in homes. That there's not only are there a host of microorganisms, bacterias and viruses, and a host of things that are part of that microecology, but all of the skin cells and the animal dander and the whatever organisms, as that all of that deteriorates and reacts with other things and breaks down, there is this microscopic film or layer on all the surfaces as you describe, and then how does that interplay with all the other things in the indoor air and the things that consumers bring into their home. None of that is understood nearly as well as we need to understand it, and a lot more research needs to be done. And then, like you said, research like what's going on with home chem, we need a lot more of that kind of science to better understand what the potential exposure is, and also to drive what would be some best practices or new strategies in homes to minimize the hazardous effects of things and try to promote a healthier environment in those spaces.
So you, the listener, now understand why I had Kevin at the end, because otherwise you would have been super depressed and probably not watched the rest of the video. But he is bringing up things that are just our reality, and the things that we always thought that home was a safe place to be. COVID has enlightened us that these are challenging environments. So Kevin, thank you for all of your time and research and all the things you do to give back to the industry. So I appreciate your time today.
Well, thank you. Very happy to be here. Happy to be part of the discussion. And anybody can reach out to me at any time. I'm happy to talk about any of this stuff. It's as exciting to all of us.
Kevin, I really hope I see you sometime in the future in person, and because besides seeing you on my monitor, every now and then. So
Absolutely. I
somehow
look
let's make that
forward.
happen. So yeah,
Absolutely. I look forward to sharing um, conferences, conversations, refreshments with you and with all of our friends and colleagues.
all right, take care. I'll see you soon.
Okay. Thank you.
All chemicals matter, all particles matter, all homes matter, all occupants matter, everything matters. I've had this slide for probably 3 or 4 years. I thank you for your time. So you can email me anytime you need to. And I also want to thank all of our participants: Les, Steve, Peter, Linda, Caleb, Bill, Kevin, Steve, Brett. You guys rocked. Thank you so much for your time. If you have a monitor, I hope you're enjoying it. And if not, I encourage you to think about which one you want to get one, and get one for your mom. Have a great day. Thanks a lot.